Okay, so power of a power. So a power of a power. That's when you have something that's like, oops, my pen stopped working. So power of a power is when you have something that is 4 squared to the third. So notice you have something with a power and it's raised to another power or exponent. So what that really means, what that blue 3 means is you have 3 of whatever's in here. So that would mean I would have 4 squared times 4 squared times 4 squared because I have to have 3 of these. So 1, 2, 3. Well, now think about what each of those squareds mean. 4 times 4, 4 times 4, 4 times 4. So then, if you look at it, it would actually be 4 to the 1, 2, 3, 4, 5, 6 power. So it'd be 4 to the 6. So think about where that came from. So if I have 4 squared to the third, I'm actually multiplying, oops, actually multiplying 2 times the 3. So I did squared times 3, or 2 times 3 is 6. So that's where those numbers came from. So if I have x to any number raised to another number, to simplify, sorry, the bells are still going off, you're going to do x to the n times m. So it'd be x to the n m. So let's write our rule for that. So to raise a power to a power, multiply the exponents. So to raise a power to a power, you multiply the exponents. Okay, now power of a product. So power of a product is if we have something that's like 2 times 4 raised to the third power. So again, we're raising a parentheses to a power. So 2 times 4 to the third power. So 2 times 4 raised to the third power. That means you have 2 times 4 3 times. So we have all of this information inside of the parentheses 1, 2, 3 times. So then you would write that as 2, 1, 2, 3, and 4 to the third. So notice what's actually happening with that 3 is it's kind of like we're multiplying it in. The word we typically use is distribute. We distribute that 3 in, but it's not exactly distributing. It's just that's the easiest way for me to describe it, is you have to give that 3 to both or all of the parts. So then if we have x times y raised to any number, we're going to give each part that number. So it would be x to the n power and y to the n power. So let's write our statement. Each base is raised to the power. So raised to the power. Okay, let's do an example. So let's say I have x, y to the 5th. You're going to take that x and y. So you're going to write it as x to the 5th, y to the 5th. Okay, what if I had, let's do one that uses all of them. So let's do 4x y squared over x cubed. And let's do a to the -1, just because I want to include a negative. Okay, I would get rid of the parentheses first. So let's multiply that 2 in. So that first step, the 4 stays the same. It would become x squared y squared a to the -1 and x cubed. Okay, next, let's get rid of the negative. So a negative exponent moves it to the bottom. So it would be a to the 1st. And then, like I was saying in the other video, I like to expand these out rather than using the subtraction rule, but it's up to you. So I'm going to do 4x y squared. There's no other y's, so that's why I'm going to leave that. And then I have x cubed, so 1, 2, 3, and then an a. So let's go ahead and cancel. So I have x's cancel, so I'm left with x. So my final answer here would be, on top we have 4y squared. On bottom we have xa, or ax. So you can write it alphabetically. So x times a, or a times x. Remember, two numbers can be written right next to each other, and we still know that they're multiplying. So that is our exponent rules. You should have gotten all of them complete from all of the videos.